So, thinking about the next few years, how do you see artificial intelligence changing things for you? Particularly if, software engineering is part of your world, either professionally or maybe just as a keen interest.
Yeah, that's exactly the kind of forward-looking question we're tackling today in this deep dive.
Hmm.
We're focusing on a really detailed analysis. It's put together by Dr. Georgios Fradelos,
Okay.
and it looks specifically at how AI might step into roles currently held by software engineers. His analysis even puts a potential time frame on significant change, like by the close of 2026.
Wow, okay. 2026. And Dr. Fradelos, he isn't just sort of throwing out predictions, is he? His background gives this analysis real weight, I understand.
Oh, definitely. Yeah, we're talking about someone with significant management experience who's been involved with AI in finance since way back in 2010.
Right, since 2010.
Yeah, and he's also the author of the Honey Badger Management Framework and the originator of the GF Accord AI Tech. So yeah, this isn't just casual speculation.
Not at all. So our goal here, it isn't just to repeat headlines, right? We want to get into the specifics.
Exactly. We want to delve into the specifics of Dr. Fradelos' breakdown to really understand the underlying factors he's considering. It's about getting beyond those broad generalizations and, developing a much more informed perspective on these potential shifts ahead.
And we know people listening have different technical backgrounds, so rest assured we're going to keep this discussion clear, focused on the insights, and, well, avoid getting bogged down in jargon.
Absolutely.
Okay, so let's get into it. Dr. Fradelos starts by highlighting some different viewpoints out there right now.
He does, yeah. He points out that while, some analyses are quite optimistic, suggesting maybe 90% of software engineers will remain indispensable, Dr. Fradelos presents a more, let's say, cautious perspective.
Cautious, okay.
And this caution hinges on a couple of really critical things he's watching closely. First, the level of reliability we actually see in AI in early 2025.
Makes sense.
And second, the practical cost, the real cost of finding and fixing errors that AI-generated code might introduce.
Yeah, that's a huge point. If the AI code is buggy and takes ages for humans to fix, well, the efficiency gain kind of disappears, doesn't it?
Precisely.
And he also mentioned something about a delay, like how quickly companies might react.
That's right. Dr. Fradelos anticipates roughly a one-year lag, a lag between when companies start seeing a real impact on their bottom line, their financial performance, and when they actually start making big strategic decisions because of it. That timeline is really important to keep in mind when we're thinking about workforce changes.
That lag factor is key. Okay, so he's looking at the timeline. But to really grasp the potential scale of this impact, he first breaks down what software engineers actually do day to day. Is that right?
Spot on. He draws on data from the 2022 Stack Overflow Developer Survey and insights from IE Software Magazine.
Good sources.
Yeah, very solid. And he outlines this typical breakdown, roughly 50% of an engineer's time on actual coding and implementation.
Half that time. Okay.
About 25% on debugging and testing. Around 15% on collaboration, meetings, that kind of thing.
Right.
And about 10% dedicated to learning and, keeping skills sharp. This gives us a really useful picture of the current reality.
Okay, 50, 25, 15, 10. So those are the main buckets. Now, how does he see AI potentially changing things in each of those? Where's the biggest automation potential?
Well, according to his analysis, the area with the most significant potential is definitely that coding and implementation slice.
The 50% chunk.
Exactly. He suggests AI could handle up to 60% of those tasks, especially the more, routine coding work.
Routine stuff like boilerplate code, maybe?
Precisely. Things like generating boilerplate code, simple algorithms, basic database operations. Those are prime candidates for AI, he argues. But, and this is important, when it comes to architecting really complex systems or understanding tricky business logic or dealing with wholly new requirements, human ingenuity is still essential there.
Okay, so AI handles the routine, humans tackle the complex. What about debugging and testing, that 25%?
For debugging and testing, his estimate is around 35% automation potential. Possible with the AI tools we have now or expect pretty soon.
Okay, so 60% of coding, 35% of debugging. That's quite a bit. What about the other areas like meetings and learning?
Yeah, collaboration in meetings, maybe not surprisingly. He sees very little potential for automation there. Makes sense, right?
Totally.
And while AI can't exactly learn for us in the human sense, it can definitely help speed up the process. It can accelerate learning and skill development by making information easier to find, providing better ways to get answers.
So AI as a really powerful assistant for learning, but not a replacement for the actual human drive to learn. Got it.
Exactly.
Now, he then takes those automation percentages and crunches the numbers to see the overall workload impact.
He does. So for coding, you've got 50% of time spent and a 60% automation potential there.
Right.
That translates mathematically to a 30% reduction in the overall workload from just coding automation.
Okay, 30% down from coding.
Then, for debugging, that's 25% of the time, with a 35% automation potential. That works out to an 8.75% reduction in overall workload.
Great, 8.75 from debugging.
So if you add those two together, the 30% and the 8.75%, you get a total potential workload automation of 38.75%.
38.75%, almost 39% of a current workload could potentially be automated. That already sounds like a pretty significant shift.
It is. But, like you said, the story doesn't quite end there, because bringing AI into the mix also creates new kinds of work for engineers.
Ah, right. It's not just taking away, it's adding to. What kind of new work?
Exactly. Integrating AI isn't just about tasks vanishing. It introduces new responsibilities. Dr. Fradelos highlights, for instance, a greater need for really thorough code review and validation of the AI-generated stuff.
Makes sense. You have to check its work.
You do. And he estimates that could add around 5% to the overall workload. Plus, the task of integrating that AI code smoothly into existing systems, making sure it fits the context, that likely adds another 3%.
Okay, so 5% for review, 3% for integration. That's what, 8% added workload overall from managing the AI?
That's his estimate, yeah, about an 8% increase.
So when we factor that in,
Right.
we had the almost 39% automation potential, but now we add back 8% for new tasks. What's the net effect then?
Well, when we subtract that 8% of added work from the initial 38.75% of automatable work, we arrive at a net reduction in the total workload for software engineers of approximately 30.75%.
30.75%. Okay, so a net reduction of around 30%, give or take. How does Dr. Fradelos translate that into future demand for engineers?
Right, so if we apply that 30.75% net reduction to the current size of the software engineering workforce, his analysis suggests demand could decrease to around 69.25% of what it is today.
69%. So basically, demand might fall to roughly 70% of current levels.
That's how he frames it, yeah. A substantial shift, potentially demand around the 70% mark compared to now.
Wow, that's a pretty significant potential change to think about. But he also stresses that some fundamental human elements remain crucial, right? It's not like humans vanish entirely.
Absolutely not. He really emphasizes several enduring aspects that AI, well, at least for the foreseeable future, just can't fully replicate.
Like what?
Well, the need for rigorous quality assurance. That remains paramount. Human oversight is still essential for reliability, security, overall code quality, catching those subtle errors AI might miss.
Good point.
Also, the sheer pace of technological change itself. That demands continuous learning, adaptation, things humans are uniquely good at.
Right, staying current.
And finally, domain-specific knowledge. That deep understanding of a particular business, a specific industry that requires human insight and context that AI often lacks.
Okay, so quality, learning, and domain expertise remain key human advantages. Now, here's where it gets really interesting for me. He touches on this idea of, just prompting an AI to build whole software systems in the future. What's his take on that longer-term vision?
Yeah, he's actually quite skeptical about that, about the idea of fully relying on prompt-based software engineering becoming like the main way we do things within the next 10 years.
Really? Why this skepticism?
His reasoning comes down to errors. Even with moderately complex code, he argues the inevitable mistakes AI will make would take a disproportionately huge amount of human time and effort to find and fix. Unless AI somehow becomes virtually flawless, which he doesn't see happening that quickly, the time spent debugging could outweigh the speed gains.
That makes intuitive sense. Even if AI spits out code fast, if it's subtly broken and hard to fix, the whole project could take longer. It's not just generation speed, it's reliability, maintainability.
Exactly.
So, okay, based on all this analysis, what's his advice? What does he recommend for software engineers themselves? How should individuals prepare?
His recommendations are very practical. They really center on adaptation. First, he says, embrace the AI tools. View them as instruments to boost your own productivity, your capabilities. Don't just see them as a threat.
Use them, don't fight them.
All right. Second, really focus on developing expertise in complex problem solving. Tackle the kinds of challenges needing deep analytical thought, real innovation stuff AI struggles with.
Play to human strengths.
Precisely. Continuous learning is also absolutely crucial. You have to stay ahead of the curve, understand how AI is evolving.
Makes sense.
He also highlights understanding agile methodologies. Being adaptable, working iteratively, that's key as teams integrate AI.
Good point. Agile helps manage change.
And finally, a really interesting point. He cautions against focusing only on trying to technically outperform AI where AI is strong. Instead, he emphasizes the enduring value of strong social skills, collaboration, teamwork.
The human skills still matter hugely. Don't become just a code bonner machine.
Exactly. Don't neglect the teamwork aspect.
Those are all really concrete steps for individuals. What about companies? What strategic shifts does he think organizations need to consider?
For companies, his message is pretty clear. Embracing AI in software development. It's not really optional anymore. It's becoming essential to stay competitive.
Table stakes, basically.
Pretty much. They need to proactively anticipate workforce changes, which unfortunately might include layoffs or strategically reorienting existing employees into new roles that complement AI.
It's a tough reality.
It is. But he also really emphasizes human adaptability. Our capacity to adapt is remarkable. He points out that entirely new job categories will likely emerge,
Oh, like what?
either directly related to managing these AI tools or maybe indirectly as a consequence of AI's broader impact on business.
New roles cropping up.
Yeah, and he offers this great historical parallel. Remember people selling CDs and DVDs?
Sure, blockbuster days.
Right. When MP3s took over, those skills didn't vanish entirely. Many became sales professionals in the digital era. Their core selling skills were rebranded, repurposed. Technology changed, but the underlying skill could adapt.
That's a really insightful analogy. Fundamental skills get redeployed even when the tech changes. Fascinating. Now, Dr. Fradelos' analysis isn't just his opinion, right? He draws on supporting evidence.
Oh, absolutely. He builds his analysis on a solid foundation of reputable sources. We're talking academic journals like the Quarterly Journal of Economics. They often explore the big economic impacts of tech change.
Right, academic rigor.
Definitely. He also references industry surveys like that Stack Overflow developer survey we mentioned. That provides real-world data on what engineers actually do, what tools they use. It gives empirical weight to his projections.
They're grounded in data.
And publications like IEE Software Magazine, which tracks trends and best practices in the field, plus influential books on AI and technology. It's a well-rounded, thoroughly researched perspective.
Okay, so drawing on academic work, industry data, and expert publications. Very comprehensive. So let's try and bring this all together. What's the single most significant takeaway from Dr. Fradelos' analysis for everyone listening today?
I'd say the core takeaway is this. AI is very likely going to have a substantial impact on software engineering. Yes, potentially reducing overall demand to maybe around 70% of current levels by late 2026.
Okay, a significant impact.
But, and this is the crucial part, this is not a prediction of complete replacement. Human software engineers will absolutely continue to play a vital role.
So not replacement, but transformation. And the real value shifts increasingly to those uniquely human capabilities.
Precisely. That ongoing need for complex problem solving, for critical thinking, the ability to learn continuously, and that deep domain-specific expertise that ensures skilled human engineers remain indispensable in the tech landscape.
Right. Adaptation and focusing on higher level skills is key. Okay, so as you, our listener, consider this deep dive into Dr. Fradelos' analysis, here's maybe a final thought to mull over.
Yeah.
Given these potential shifts in software engineering, what other professions do you think might experience similar significant transformations in the coming years because of AI? And maybe more importantly, what proactive steps can individuals in any field start taking now to prepare for an increasingly AI-driven future, thinking beyond just the world of code?
That's a great question. It really pushes us to think about the broader implications, doesn't it? How work itself, how we live, might change. Something definitely worth considering.